I was looking at abundance of stuff on site 1 and site 2. I got some big counts here. I got quite a big spread of data here. On the second site, there wasn't a lot that I found, lots of repeated zeros clustered. So we're doing a two-site comparison, so we're going to go ahead and get this into Data Classroom. And we're going to start by looking at the spread of data, but on your spreadsheet you can put in equals average. Oops, let's type that in, average. And this is the mean, so average on a spreadsheet is mean. So look, the means are, really, really different. So it feels like we've got quite a difference between the two sites just by looking at it, right? So there's many zeros found on site 2. The standard deviation equals dev, and that will get our error bars. So how variable were the stuff that we found, right? So 7 here and a 0.8 here. Okay, so what do we do with the data? Well, we have to change the data. We need to change it from what we call short form to long form. And here I've done it, right? So we need 2 columns, site as a variable and abundance as a variable. So once we've got the data like this, we can copy it and we can get it into Data Classroom. We can import the data and paste data from a spreadsheet. It's exactly what we've done there. And my new data set here, this is going to be 2-site, and I'm going to 2-site clusters, right? So there's a lot of clustered data here. I'll save it. Now we have to say the site is a category, okay? So category 1, category 2, location is a categorical variable, and this is a numeric variable. And that's it, just these two. Click on graph, switch to graph tab, and we're going to bring both variables down to the right bar. We're going to put this so we see the dots, category, site on the x-axis. There we go. So that's kind of what we wanted to see. And we can kind of see already a problem, maybe. Now if we go to descriptive statistics, here's the mean, and if I see the values, look, the mean 4.56, right? And 0.625 standard deviation. So these are the same numbers as we found on our spreadsheet, right? So look, the error bars here though are kind of overlapping, right? Because you've got these quite extreme points and big clusters here. So although the means look considerably different, the reliability of our mean is called into question because of these big error bars, okay? So that the natural test for this is there a difference between the means? And when we click this little magic button here, it takes us automatically to the t-test. But when we do that, we actually need for really the data sets to be a certain shape. And if we have a look at the data sets here, we want there to be no extreme outliers. And it looks like these are quite big values up here, right? And also the data set needs to be approximately normally distributed. Now you can't really say visually on here whether this is normally distributed, but if we actually go back to this picture, you can see this looks quite nice, but I'd love to actually just have these as different data sets. So I can go to this cogwheel here and let's exclude my second site data, and here's the abundance in the first site, right? A big cluster of zeros, right? And then quite extreme values. So if I actually show the normal distribution on here, yeah, okay, I'm not too sure that this picture fits a normal distribution, right? And if the data's not approximately normally distributed, then comparing the means is a kind of a big no-no. So there's a magic button here, testing normality, and we usually use the Shapiro-Wilk just because of the sample size. Let's run the test. So the p-value is less than, well, p-value is tiny. So basically the conclusion is that after this particular test is running, we actually have a conclusion the data is not normally distributed. Okay, so done. There's no real need to test the other data set, because if one of the data sets doesn't exhibit the right properties, then the 2-sample t-test is inappropriate. So let's just go back. Let's get both data sets on. Let's go back to our nice picture, which was this one. The means now are no longer kind of valid in the test that we're going to do. So I'm going to change to a median-based visual. Can you see that? You can see that just the big spread. And look, the median value, the medians are 0 for both. All right, so testing for the difference between site 1 and site 2, we're going to do a different test now. Click on here, we're going to go to the advanced options, and now we have to switch to this non-parametric test, all right? And we use this test if the data isn't normally distributed. So t-test would have been the ideal one, but now we need to do the Mann-Whitney, so we need to force the computer to switch to Mann-Whitney, and we calculate. And when you read it, it's similar to a t-test. It's used where the dependent variable is not normally distributed, okay? And so it talks about, the way it does it is here, but we don't really need to know that. We just need to calculate the p-value. And look, the p-value is 0.47, and it's little to no indication that the groups might be different, all right? So the conclusion here is because the medians are actually the same at both sites, there's not enough evidence to suggest that the overall abundance at site 1 is greater than site 2, okay? And that's fine. Sometimes in ecology studies we find a result that is not significant, and that's absolutely fine. We can still report that in our paper.